from learning that. So let's continue. Okay, continue with the factoring. So in this case, if I need it to be a negative 13, that means I need to owe 14 and I need to have $1. Agreed? Right, that's the only signs that would work. So here's the next step. You put two parentheses. Okay. Remember we did that, right? That comes from two parentheses. And then you put the plus 1 and the minus 14. It doesn't matter where you put the 14 and the 1, like they can be opposite sides, but you have to put them both there, okay? Now the next part is this. We have to put this, this 2 here and here. Whatever that number is, you put it down twice. And then the x will come from x times x. X times x is x squared. Now the catch with these is that one of these 2's is not, it's a fake 2, okay? Or maybe both. We're gonna find out which one is fake. So one thing I want you to always do is the first 2 parts, so these 2 are the binomials, those 2 need to multiply back to this, always. So right here, if I do 2 times 2, that's not 2, right? So something is wrong. That's the key that we need to do something else, okay? Same thing with these 2 numbers. These 2 numbers right here at the edge, they need to multiply to that number, which they don't. 1 times 14 is not 7, okay? So that's the hint that, hey, I need to do something else. So what we do is we reduce. Can we reduce this one? 1 and 2? No, right? But could we reduce 2 and 14? Absolutely, by what? 2, right? So we divide by 2, divide by 2. Or reduce by 2, reduce by 2. And so now you have this, 2x plus 1, x minus 7. Okay. Now, I do that really quick check. This 2 times that equals 2x squared. Yes, and this 1 times 7 is negative 7. Yes, so that would be your answer. Right here. Is that all right, guys? Okay. Let's, before we continue, I wanted to give you this real quick. It's an analogy. I made myself a note so I don't forget, because I refer back to that analogy throughout the year, and if I don't explain it to you, you're going to be like, what is he talking about? Okay. So real quick, let's pretend, you don't have to do this on your notes, okay? Just a little pause in your notes. Let's say this class, pre-calculus, 7th period, is a boat, okay? All of us are on this boat. Me, you, everybody, we're on this boat, okay? And we just left the shore. We just started class. We're in our 3rd day of class, 4th day of class. We are all going to the same destination, right? What do you want to do? Finish this class. You want to pass this class. To graduate, to get your 4 math, whatever the reason is, right? But you want to pass this class. When I was in your seat, guys, just like you in class, okay? The teacher would do something, right? 10x, and I was lost, and I wanted to ask, Mister, why did you get 10x? Right? But what would happen to me personally is, as soon as my mind wanted to ask that question, my heart would just start beating like crazy, and my hands would get sweaty, and I'm like, I'm not gonna ask nothing, because I would get nervous, and I wouldn't ask nothing. I think I would never ask nothing in high school because I would get so nervous. And so that's analogous to this, okay? That's like if somebody, if that's you and you sit there and you don't ask that question, that's like if you fall off the boat, okay? Because we all have the same objective, right? We're trying to finish this class. When you don't understand something, now you're not going in the same path because you're getting lost. But here's the catch. If you ask a question, right, when you have that question, I can answer that question because it's right here. Oh, I got 10x because, see right here, I multiplied 2 times 5. And then we fix it right away, okay? And so what happens is you're so close that I can just pull you back on the boat, right? And now you're back with us. Now we're moving together again, okay? But what happens is if you don't say nothing, okay, you just stay quiet, well, then that boat starts to get further away from you, further away from you. And it's harder and harder to get you back on the boat. And I'm not just saying that for this lesson, like it's true for the lesson, it's true for the unit, it's true for the week, it's true for the month. You get what I'm saying? The more time goes by and you don't ask for help, it just gets further and further away. And then before you know it, we can't get you back on that boat because it's just too far away from you. Okay, so I'm just trying to encourage you guys to be brave. If you have questions, ask. Okay, don't wait, because it does make a difference. So anyways, now if I say, are you on the boat, or get back on the boat, now you know what I'm referring to. Okay, so let's continue. Number 2. Okay, let's see how we did. Try this one. 4x squared minus 13x plus 9. Can we give you 10? It works the same exact way. Same exact way, no tricks. You know, and once you multiply those two outside numbers, and you get 36, right? Start dividing 36. You know, if you can't think of the numbers that work, do 36 divided by 2, 36 divided by 3, 36 divided by 4 in your calculator, and you start to build that equation, right? So you don't want to use decimals, you want to use the whole numbers. Those are the factors. Do you know which one's first one? Okay. So if you do that quick check, 4 times 9. Yeah, it's horrible. It's like the worst calculator they could read. Yeah, it takes some getting used to for sure. very good, guys. I like where y'all are. Some of you, okay, so anyways, you make your list, right? 1 times 36, is it 2 and 18, right? 3 and 12, and so on and so on. And you can make a list like that if you're dividing down, okay? Or if you're really good with your multiplication facts, you know, you might be able to get right to it. But sometimes you can't, sometimes it's good to list them out. The point is that there will only be one choice that works, okay? At first, all I want is a 13. Okay, there it is. But now I have to make it work with a negative, right? It has to be a negative 13. So the only way that will happen, and if you think about money, right? If I owe $13, that means I have to owe 9, but I also have to owe 4, right? In order for me, from my point of view, to owe a third. And I'm exaggerating this part because that's the reason students miss this the most, okay, with the signs. They get the signs wrong. So that's how you have to think about it. I owe 9, I owe 4, so from my point of view, I owe 13. Okay, those are the winning numbers. So any question up to that point? No? Okay. And then here's the next part, right? I have to put this twice, 4x, 4x, okay? Now, that's why it's super important, guys, that you check your answers. Like, if you think that's your answer, all your answers, always check them to see if they're true, okay? And this is how you check. You just multiply in your head. It takes 2 seconds. What is this times that? Because it should be that, okay? And not only that one, check this one too. This one times this one should be that one. And as you can see, neither of them are true right now, so that's not my final answer, okay? Oh, okay, so that must mean I have to reduce, okay? So this one reduces, right? Now check this out, right? Some of you already did it all the way, but what if like you reduced it by 2, which is fine. Not always you're gonna reduce, you're gonna find the GCF right away, and so you're gonna reduce by something else. So let's say you did by 2. Notice again, if I check my answer, right, is this times this equal that? No, right? So something's still wrong, okay? Don't just assume it's right. And that's because I forgot right here, I can also reduce that one down one more time, okay? Because both of the 2's can be divided by 2. Now, I could have prevented all this if I would have divided by 4 in the top part. But if you forget, then you can just reduce and it gets to where you need to be. So this is the final answer. Okay. Notice this one does work, right? If I multiply this times this, that's 4x squared. If I multiply this times this, that's positive 9. So don't worry about the middle one. If those 2 work, the middle one would work out too. Okay. Be honest with me, how many of you had this answer? I just want to see as the class where we're at. Okay, it's pretty good, we're about 60%. It's gonna get better. That was number 2. Questions, guys, any questions so far? Okay, let's try number 3. Okay, factoring is huge, remember, huge, huge, huge. And you're gonna get better and better. Okay, let's do 10x squared minus 21 plus 9. Okay, I picked this one on purpose because even if you're good with your multiplication facts, you probably don't know all of the 90s. So it's gonna force you to have to use your calculator, and that's on purpose. Not always you're gonna know all the factors, so you have to know how to get them if you don't have them, right? So you just take 90 and you divide it. 90 divided by 2, 90 divided by 3, 90 divided by 4, 90 divided by 5. Unless you're super good and you know it off the top of your head already. Which honestly, that combination wouldn't have registered to me right away. And as you build you start dividing, just build your list, right? We'll do lists until you find one that can get you a 21. It doesn't have to be negative yet, just a 21. once you find them, I encourage you to think about money, okay? It'll make you that much faster, efficient. Think, do I have to owe this money or do I have this money? So at the end of the day, you wanna owe $21. And as you practice more, you'll get faster. Them, you get 1. So there's no way you can get 21 from those. You gotta think of more. You get what I'm saying? Oh no. So the rule is like whatever you divide by has to go to both.
Okay.
So like if you divide this by 10, this has to be divisible by 10.
Okay, so it's 5.
On this one.
So if I pick on this one, it has to be
It has to be
really.
equal.
Okay. So 3? No. Wait, yeah, 3.
Okay, guys. Excuse me. It helps, okay, if you, especially at first, to just make that list. Like if you don't know like how to start and get going, if you're kind of stuck, just start making your list of all the numbers. Just start dividing 90 divided by 2, 90 divided by 3. And then, you know, you'll, what's it called? You'll make this big list, right? Once you have your whole list, then you can see which of those 2 numbers can make you a 21, right? Which in this case, it's 6 and 15, right? Which that's the one, like, I probably wouldn't have thought of that one right away, okay? So here's the list, okay? Those won't work, and it has to be 6 and 15. And this is where I encourage you to think about money, like, out of those dollar bills, if I need to owe 21, right? That means that I need to owe both of them to be a total of owing $21. Okay, and then the next part, you automatically put 10x, 10x, minus 6, minus 50. Okay, which we're doing great at, okay? A lot of you got stuck at this part, or you're kind of there for a little bit, right? But this, you check, 10 times 10 is not 10, right? So that means that you have to do something else, and that's when we reduce, right? So what number goes into both of those? 2, right? So I reduce this by 2. Now I'm trying to simulate like when you're doing this, right? Because sometimes it doesn't occur to you and you're like, oh, reduce, I'm done. But then if you check again, 5 times 10 is not 10. Okay, and that'd be your hint that, oh, there's more I need to do, right? And in this case, this one doesn't reduce no more, but this one does. Right, one number goes into 10 and 15, 5, right? So I can reduce again by 5. So for this particular problem, I had to reduce it twice. Or both binomials had to be reduced, right? Now notice, that's 10, right? And 3 times 3 is 9. So there's the right answer. Question, guys. Okay, be honest with me, how many of you had that final answer down here? We're good. Okay, very good, very good. I know some of you are still like doing the fine-tuning details on there, but okay, number 4. All these have like a little bit something to teach you. And you're gonna get better and better. Okay, here we go. Okay, very straightforward. The only difference is x to the 4th, but it works the same way. It works the same way as the other one. So, but instead of doing x and x, you have to think about what times what would give you x to the 4th this time. Right? But it's the same process. Oh, I needed to say something about this. What did I tell you guys always to multiply the outside numbers, right? And you're like, oh wait, there's no outside number out there. But there is, right? What number is there if there's no number there?
1.
So it's 1 times 4. Okay, so you're looking for multiples of 4, which there's very few, there's just 2 pairs. And only one of those pairs will add to a 5. For those of you that are catching on pretty quick, you already have the answer. Ask yourself, is there anything else I can do? You did it right here, but then you mix yourself up. So the numbers that work, those are the ones that okay, I must dip in, okay, I know you are working, but, because you're at this special place right now. So, 1 and 4, right, that's the only way this works. Right. So, I owe 1, I owe 4. And then what kind of x goes here and here? X squared, okay? I didn't see it here, but in other classes, I saw just x and x, right? That would give you x squared. I saw x4, x4. What's x4 times x4? x8, right? So now, okay, so it is 2 times 2. Okay, so 2 and 2. You add 2 and 2 is 4. Okay, so a lot of you had this answer when I was walking around, all my classes. But think back about what we were doing yesterday, right? Does this look kind of familiar, like any of the problems that we were doing yesterday? Anybody remember the name by chance?
Wait, the thing we're supposed to
The name of this type of problem. It is a binomial. And then the minus was like the difference of squares, right? Are these squares? I don't know. Is that a perfect square? Yeah. Remember what perfect square means? Is there anything times itself that gave me that? X times x.
Oh, yeah.
Right, and x is the same. What about 4? Is that a perfect square? 2 and 2. And it's a minus? Yes. If you answered yes to all those questions, it's the difference of perfect squares. So remember how those work. You make 2 of them, one of them is plus, one of them is minus. and then you break up the squares, right? So x, 2, 2. Now, a lot of people catch that one, but a lot of people miss this one. Is this a perfect square? Is 1 a perfect square? Is there a number times 1 that gives you 1? No, sorry. Is there a number times itself that gives you 1?
1.
1, right? What's 1 times 1?
1.
1's a perfect square. And we miss it a lot, but it is a perfect square. So, yeah. So it also breaks that. So x plus 1, x minus 1. Okay. It's really natural and normal to miss that the first time you see it, because you're like, oh, I just factored a trinomial, I'm done. Okay, but sometimes you can go further. Once you see that once, you'll probably catch it next time. Okay? Questions, guys? Good? Okay. Everybody on the boat? I hope so. Okay, number 5. Because we're going to go to wonderful places along the way, so I want you to be on the boat. Let's put, hold on, let me change this. Instead of negative. Okay, I want you to put this on your notes, okay? If you see a negative in the front, okay, always remove. This is how I abbreviate the word negative on my notes, thanks to one of my engineering teachers. But if you don't like to do that, just write out negative. From, I say the front, to me that's the front. Some students call that like the end, the left side, or whatever, this side, okay? If you see a negative here, take it away, okay? I'm gonna show you how to take it away. But you don't wanna do any problem that has a negative in the front. It creates all kinds of problems. Bless you. Okay. So here's how we fix it. Let me walk you through this. There's no number here, but there really is. What's the number there? 1. What kind of glue is holding the 1 and the x together? There's a glue there that's holding them together. Multiplication. Okay, multiplication is the glue that holds a coefficient and a variable, a number next to a letter together. So if you want to undo the glue, you do the opposite of multiplication, which is 5. Okay. Now that what I did right there is illegal mathematically, okay? Because you can't do it to one term, but you can divide by whatever you want, whenever you want, so long as you do it to everybody. You just have to be fair, okay, to everyone. So as long as you do it to everyone, then you're good. Okay. All right. So now check out what happens. Negative divided by negative is a positive. Negative divided by negative is a positive. Negative divided. And we didn't have a positive, but a positive would have turned negative. So in essence, what really happened here, notice just the signs just switch. Negative to positive, negative to positive. If you know that in the future, if you remember that, you can just switch all your signs. That's what I mean. Now, I have an important question to you. Should I keep this negative 1 over here?
No.
You'll have that question a lot of times. Okay, sometimes you do, sometimes you don't. Let me show you the difference. You always need to have a way to get back to the original problem. So if I don't put that negative there, I can't get back to this white problem, right? But I need to be able to get back. So I need to leave it there so that if I need to, I could distribute it back in there, and then that negative would go back in there. That's how you decide if you keep it or you don't. Does that make sense, guys?
Mm-hmm.
Okay, we'll stop here. I just have to finish the note. It's gonna take me like 2 minutes tomorrow.